Hi guys, today we're starting with parametrics. Actually, we're finishing parametrics also. Parametrics allow us to study horizontal motion and vertical motion separately. We most commonly think about this with respect to airline flight. Instead of simply solving for y in terms of x to graph it, it is easier to solve for x using t and y using t. To do so, you want to use easy values. Notice how every number on this table simplifies in the x equation easily. So I chose t equals 2 because t minus 1 is 1, which is the square root of 1. Which is the square root of 1 is 1. I can't talk. Okay, so same with 5, same with 10. Notice I didn't choose any numbers that give us crazy decimals or crazy square roots. The next thing you want to do is solve for t in both the x equation and the y equation. Once you've solved for t in both equations, you can set t equal to itself and solve for y. This gives us an equation for y in terms of x. It also gives us a direction on our graph. Plot the points, connect the dots, and indicate direction with the first points leading towards the second, towards the third. And this is more obvious as we go forward. On the second one, you are going to want to use specifically the t values in the domain. Once you've found all of your x and y values in the domain using these equations, you're ready to graph. This is where direction becomes more obvious, so I'm going to take you through this. You start with the point 1, negative 4. Y'all, this is what I hate about it. It misbehaves for me. Why, Emmett, why? Help me. 1, negative 4. Nope, I can't. Okay, I have to pause. Okay, so you start plotting your points, and you're going to see that it's going to make a sideways parabola. Except I did one of those points wrong. Oops, fixed it. Once you've made your dots, you connect them in the order that you graphed them, and you put arrows on the curve indicating direction. Lastly, we need to solve for t in both equations to be able to put x in terms of y. Quickly solve for t, and finally put y in terms of x. Notice my highlighted correction above. On our third example, we need to set up an XY table, which in this case would be a TXY table. Now you either put together your table using your unit circle, or you can always use the table on your calculator, and then you graph. Look carefully. I made some calculation errors and I fixed them in purple. Once you have completely filled out your table, then you graph your points. Check your graph by looking at Desmos or your graphing calculator. You have parametric mode on both. If you need help with that, I will try to help you when I can, hopefully during class today. Now we need to look at our derivatives with respect to y and x, and in fact, our derivatives with respect to y over x, which requires that we use our derivatives in a new and different way. If you look carefully, dy dt equals dy dt over dx dt, dy dt over dx dt, yes, which does not simplify in a way that we expect, particularly when you take the second derivative. And if you look at this second derivative, you can see why it is called dx squared and why it is called d squared y. That is the explanation I promised you a bazillion years ago. So the first thing we're going to do is find our derivatives with respect to t for both x and y. Those shouldn't be a problem. From there, you take the derivative of y with respect to t and the derivative of x with respect to t and divide them, and you get, ta-da, dy dx. So now we found the derivative of the derivative with respect to t, but we need to find it with respect to x, so we need to divide this expression by dx dt. Ta-da! And again, if you need help understanding why these two 2's are here, look up at the top at the other highlighted section. On the second example, again, find the derivative of x with respect to t and the derivative of y with respect to t, and then divide. You can simplify this if you'd like. Just keep in mind your domain. So we have 10t cubed minus 9t. And we are going to find, oh, you guys, what? I'm doing the wrong problem. Y'all, what a waste of time. I don't even know how to erase it. I just did this to make you giggle. Not really. I'm mad at myself right now. I don't know how I was doing the first problem. Gosh. Okay, there we go. Now, take the derivative of x with respect to t, the derivative of y with respect to t. Then we're going to find dy dx by dividing these two expressions. Divide and simplify to find the slope. Find your x value at t equals 2 pi over 3. Once you found your y value, go ahead and find your slope at that point to be able to create the equation. You will want to, for the sake of time, keep your line in point slope form. If this is a free response, which it probably will be, you will want to leave your answer in this form. You do not want to waste time with the algebraic manipulations and calculations. You're super likely to make a mistake there. On example 3, find your derivative of x with respect to t and your derivative of y with respect to t. Once you've done that, you need to find the vertical tangent and the horizontal tangent, and those are found by setting the derivative of x equal to 0 and the derivative of y with respect to t equals 0. So you want to do each one individually equal to 0 so that you can find when the numerator is 0 and when the denominator is 0. And what do I mean by numerator and denominator? Remember that dy over dx is in front of you with this piece right here being your dy over dx. And this piece right here, I think I said the wrong thing. I think this over here is your derivative of y with respect to t, and this is your derivative of x with respect to t. And all you have to do is divide the first one, this one by this one to find dy dx. And here you go, your initial t values for your horizontal tangent and your vertical tangent. You just need to find the x and y values at the horizontal and vertical tangencies. There are your vertical and horizontal tangent points. There is a possibility that you could have more than one vertical point of tangency and more than one horizontal point of tangency. So keep that in mind if you have functions that are more complicated. Take a moment to read this page and come at me with questions. I feel like this is way easier than it looks. You're just taking the derivative of the x with respect to t, squaring it, plus the derivative of the y with respect to t and squaring it. So it's just the arc length formula just for parametrics. So we'll talk about it in a second. Go ahead and read it. When you get back down to the example, you take the derivative of x with respect to t and the derivative of y with respect to t. So take that derivative, remembering chain rule, and all you need to do now is pop it into the formula. Ta-da!